Thanks very much. So, as the title says, different data, same information, dynamic consumption. I'll give you a bit more detail on what all that means very soon. So, I'm Todd from Christchurch, New Zealand, and pretty much spend most of my days working on FME and been working on FME for 10 plus years. But what I'm going to talk to you today is about a regional council in New Zealand, which is called Environmental Canterbury, and they cover a big region of Canterbury, which is shown by the green area in the map of New Zealand, and on the right map, they're the 10 local councils that sit below it. Now, each of those councils collects rates against properties, so basically land taxes, and a portion of that goes through to Environment Canterbury. But one of the things that Environment Canterbury want to do is get all that information, because they don't actually store it themselves. They need to be supplied that information from all those councils. And they also get the full file every month from each of those councils. So it's a bit of data, but not too much. So what's actually happening? Each of those councils is supplying basically the same information within a file, but it all comes in different ways. So there's kind of a different data schemas, there's all sorts of different things going on, and each council does it a different way. And so what do I mean by that different data? So each thing is provided with a different schema, so different field names, different delimiters. So that could be most things come in a format that might be a text file, CSV, or something similar. So there's always a kind of a delimiter in there, but it could be a tab, it could be a pipe or bar or whatever you want to call it, or it could be kind of anything. They also have different coded values. So what I mean by that is one council may show yes as 1 and no as 2. Another one might show 5 as yes and 0 as no. So that changes basically depending on how the different council systems work. And all the information, though, can be used to either fill in the final output or can be derived to create the exact same information across all the different councils. So there's a couple of examples there of the 2 header rows in 2 of the councils. So as you can see, the first one has got tabs and a few different names. The second one's using pipes or bars, depending on what you call them. And some of the names are different of those table names. So how did they used to do this? They had a process that worked. It worked really well, but they thought it could be better. They had a few issues. They also outsourced it all. So they got an external company to go and collect the information and provide it back to them when then they would process it. And this whole thing came around because that external company decided that they didn't actually want to continue doing that. So it came back was going to come back into council, and they thought, well, let's see if we can do this a better way. And they had 16 stored procedures in SQL or in SQL to actually load all this data. So there's 10 different councils, there's 10 different stored procedures to do the actual first uploads, and then there was another 6 to configure everything and make sure everything was correct, etc., before getting loaded. So I got a brief of what they wanted, which was, this is an organisation that's already got FME server and FME desktop, so they wanted to move it into FME. They thought that would probably be an easier place to manage it, and they wanted to reduce the hard coding that was involved. So each of those stored procedures was hard coded, so every time a council changed a value, they would have to go into the stored procedure, make changes, make amendments through it, and do all sorts of stuff. They wanted to do adds, deletes, and updates. So rather than loading all the data into the relevant things, they just wanted to get those things that had changed. And they already had that, but they also wanted to continue that. And then they had a few nice to haves. So the ability to archive old records, so anything that had changed to record the previous values. They also had an ambition to put it onto FME server in the future, so that they could use a whole bunch of notification type methods to get it to, so that people could either email in their information, they could go to the web UI, or they could upload their information through a number of different methods. And they also wanted to QA the data. So there were some of these councils, one particular council has a base of 2,000 people, which means the council itself is about 5-6 people in the whole council. So, they don't have time to go through making sure all the data is right before they send it off to the big regional council. So they wanted to be able to QA that when that came in. So I wanted to go a bit further than what they had suggested. I wanted to avoid all hard coding, and thought about this for about probably a day in terms of, what am I actually going to do? How am I going to avoid any hard coding within the FME script? And basically came back to the schema mapper. So I'm not sure how many people have used schema mapper, but it's very powerful, but also very complex. So some of the things you can do with it is that you'll see in the first bit is you can recode attributes. So being able to change existing values to new values. As you can see on the top there, we're changing 1 to yes, 5 to no for one particular council, and then down the bottom you can see 1 to yes, 2 to no for another council. We also wanted to map the schema, so had another. So actually, I'll take a step back and just say that the schema mapper is reading tables external to FME. So that could be an Excel spreadsheet or in a different database, and these are different tables within that. And so the map schema again was looking at an external table, looking up what the actual name of the attribute was in the council supplied data and then what it should be. And down the bottom, I added these things, which I just called key fields, which was where we had an actual schema output. I didn't want to hard code. So if someone came along and changed the name of a particular output, I wanted to not have to hard code that in. So I actually had a whole bunch of things where area, land value, and capital value, etc. They were hard-coded in FME, but they didn't actually relate back to anything in the data. But this way, I can create an association in the schema mapper that would allow me to get those associated fields and do a whole bunch of QA on them. And then out on the other side, I would actually create a schema, so an output schema derived from an input list. So the schema on my writer doesn't exist. It actually gets created from the list that's attached to each feature. So one of the problems that I created for myself by doing this though was when I made everything external into tables external from the process, I thought, well, actually I need to QA those tables because I may have put something wrong in them, and in the future when that's maintained by someone else, they might have a double up or something, and so we need to do a whole bunch of queries against that and make sure the data's right. So we also have a whole bunch of checks in there, checking those external tables that are used in the schema mapper to make sure there's no duplicate references, no missing requirements, that there's the appropriate field types, the right amount of fields, and a whole bunch of other things. And another thing I needed to do, each of these things were coming in the delimited format, but I didn't know what the delimiter was. In FME, there's currently no way to guess the delimiter, so I had to figure out a way of making it guess itself. So, in other words, the FME needs to be told what the delimiter is in a CSV reader. So what I did instead was read in each file as text, and then query what type of delimiters were in that particular, in a number of rows. And then once I could figure out what the delimiter was, then I could pass that into the feature reader and pass in a value that provided the delimiter. And then later on down the track, we had to do a bit of change detection. So as I mentioned before, we have a whole bunch, the information is supplied in full from each of these councils every month, but we are only interested in the changes. And so actually what we needed was a change detector to figure out what had changed. So basically we end up reading all the data that was supplied in, that exists, to compare it against with what is coming in from the councils. But if I talk about some of these files, the example files were 24 columns. If you go through it in Change Detector and say compare these 24 columns, it becomes actually quite cumbersome because it's going to go and check each field. So first up, and this is probably where a change detection could be actually a bit better, and you can use other options such as the feature merger and CRC calculator to do some of this as other options. But what we ended up doing was concatenating a whole bunch of information with certain separators and then providing those together and then running that across the data. So, if, for example, those 24 columns would get concatenated all up, checked with what was coming in with the new data, and if there was any differences, then we knew something had changed. We didn't know if it had been updated or deleted and stuff, but then we could actually push it forward into a second change detector that looked at a couple of fields which were related to sort of primary keys that we could actually say whether this was a new feature, whether it was deleted, or whether it was a change. And so that accomplished it a lot quicker than trying to compare every field. So the other process that's quite nice about that is that once you know what has been deleted and stuff, you can actually start to pass them through. So not only would we use a delete on a feature to delete the feature back in the proper table, we'd then also use that delete to insert into our archive table. So basically doing two things at once. And it was just it becomes quite easy to archive a whole bunch of stuff quite quickly, and making use of the FME DB operation to do that with the updates, inserts, deletes attribute. And yeah, made it quite easy. So this is the final workspace. There's quite a bit more to it than some of the things I've been talking about, but it's not as quick as running it in SQL. There's no denying that. But this process is one process. It will run for all 10 workspaces. All 10 suppliers. There's nothing to configure within the workbench, and it just works. And so some of the outcomes that actually came with it was that it can consume multiple rating inputs, and like I said, it replaces those 16 stored procedures. By doing that, we've reduced down what maintenance needed to occur. There's only, if they want to go through and add anything in future, any additional QA, it becomes quite easy. It's only in one spot. FME Workbench was not required to be changed when an external supply changes. So someone else can manage the external tables. So it doesn't need to be someone within the GIS team or the related FME team that actually has to go in and do anything. So they can be all maintained externally, say by the finance team that actually gets the information. And they now also have reporting. So a couple of weird and wonderfuls that came out of actually testing this out was that we had examples where one of the councils had a number of properties where the total value was less than the value of the land. And there was another council that had listed a property that was equivalent to a quarter of the size of New Zealand. And, some of these sizes, actually I had two. So they were basically saying, we can contain about half of New Zealand within this tiny little TA. or a tiny little council. So it really pointed that out. And also, while they still kept that information, we had outputs that would get created each time that could be sent off to those councils to say what we thought was wrong within their data. But also in future, when that goes up onto FME server, that can be instant feedback. So they can upload their data, get it straight back and see what is actually wrong with it. And the funny thing was, what I found out later was the cost of writing this whole script was equivalent to what they were paying their external contractor each year. So even though they had an external contractor doing a whole bunch of getting the information and passing a whole bunch of stuff before passing it through to the council, before they loaded all the stored procedures or loaded all through the stored procedures, that was just the initial cost is what it cost to do the whole FME process. And I suppose the one thing that I think a lot of people in the FME world miss is that this actually has got no spatial data in it. This is just completely non-spatial. And I think one of the things that I've always been amazed about FME, and the people have kind of grown to know it, is that FME does provide sort of business solutions, not just spatial solutions. Thank you. Any questions?
Any questions?
Yep.
I have a question. You had said about how it's undeniable that it was still faster with SQL. What about the memory consumption? Was it?
So there is memory. So in the terms of the change detector, there was some memory consumption in there. But as it, like I said, actually, if you went through like a feature merger, so it depends. Basically, you could get it down really low. So if you use feature merger with suppliers first, which switches it from a group-based transformer or blocking transformer to a feature-based transformer, that's probably getting quite technical, but it changes the way. It doesn't mean it doesn't get all stored in memory. Just one table would get stored in memory, and then the rest would just fly through.
To get a context, like how many rows of data were you looking at?
Oh yeah, so this is not a big data set, but what are we talking? We're talking I think in this one, it'd probably only be about 500,000. But saying that, they number of columns is going up to about 160. Yeah. Sweet.
Any other questions? How long has this system been in production and use?
That's a good question. It has been in production for 7 months now.
7 months?
Yes. I haven't actually seen too much of it since it went in because I've been too busy in other places. But by all accounts, it's working well. And so it's it's probably one of those things where in the end, I was actually quite surprised that I was able to do it without any hard coding within the process. But, that's kind of just what I aimed for at the start. Yeah.
Any other questions? No? All right, well, thank you very much, Todd. Really appreciate you coming out and